Hi all, this is Mr. Yeager doing physical science, and we are looking at the unit on matter. In particular, we're going to be breaking down the different compositions of matter, basically the difference between pure substances and mixtures. We will later look at, in a different video, the states of matter, solid, liquid, and gas, and we'll also look at physical and chemical properties. So, here we go. How can we compose matter? How can we break it, basically break it up into its pieces? We're going to be looking at a lot of different vocabulary words. You can see them all here. I'm not going to say them now because I'll say them in a little bit. But again, we're not looking at solid, liquid, and gases. This is more the idea of, do we have a homogeneous mixture, a heterogeneous mixture? Is it a pure substance? Is it a mixture, etc.? So what do those things mean? Okay. So first off, what is matter? Okay. Matter itself is basically everything in this world is essentially matter, except for really light, okay, and sound. That's basically it. I mean, anything that's around us that has mass and volume, okay, is something that is considered matter. So matter are objects. Again, we don't necessarily have to see it. Again, the air around us is matter. It has volume. It has mass to it. It's made up of particles. All right. Again, we just finished up the atom. Atom is matter. Atoms are particles with mass and volume. They take up space. Very, 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 very tiny amounts of space, but they still take up space. Okay? So matter is basically everything. Again, the only examples that we really interact with that wouldn't be is light and sound. There's other examples, but I mean, I feel like they get kind of abstract. All right, so matter itself can be broken into two large categories. We either have mixtures or pure substances, okay? And so pure substances is basically the idea that object, that piece of matter is made up of just one type of element or compound, okay, essentially. So that would be considered pure substance. I have onions next to it, but that's just part of my kind of description and showing of it, okay? Onions are a mixture of different compounds, but the idea is it's uniform. If I said, here's an onion, and I cut a piece off of it, that's still a piece of onion, okay, is what I'm trying to say. That would be the same thing with pure substances. We're going to get to more specific definitions of them in a moment, okay? So anything that's just one type of matter completely, that is a pure substance. Mixtures, on the other hand, is where we have two or more of these pure substances that are just combined. I don't want to say mixed because it's mixture, but they are put together, okay? But the key part is they don't chemically react with each other. If that happens, we might have a new pure substance. These are things where we still have all of the individual properties of each substance. So that's why I have the picture of a salad here. Okay? This is now a salad mixture. It has onions, it has croutons, it has salad, it looks like some walnuts, has some other things in it too. Okay? When I take a bite of that salad, I'm going to be able to sit there and be like, ooh, I got an onion. Oh, this is the crouton, this is the lettuce, this is the spinach. Okay? All of those things still remain what they are. I have just put them all together. All right? Another classic example of a mixture is basically a box of crayons. They're all crayons, but they're all different colors, and I can see all of them together. Okay? If the idea is this is a mixture because they don't chemically react. It would be really weird to throw an onion onto some lettuce and all of a sudden just see it meld into it and become something new. It will taste different, it'll look different, it'll smell different. That would be really, really, really odd. Okay? So pure substances, one type of matter, one type of object. Mixture would be multiple objects together, but each one retains their own properties. Okay? So there are two basically types of pure substances that we have out there. We have elements and we have compounds. Okay? Elements, as we already talked about a little bit in the last unit, are basically one type of atom is in this element. So I had that picture of gold. When I have pure gold, and actually it's really tough to get pure gold. Actually, it's not too tough, but it would, there's usually other things mixed into it, impurities mixed into it. But if I had pure gold, that would be elemental gold. All right, that is, it cannot, as it says here, be separated by physical or chemical means into anything else, because at that point you're splitting up the atom and trying to basically cause some sort of nuclear reaction versus chemical reaction. All right? So elements are just one type of element, one type of atom. Compounds contain two or more different types of elements. All right? And these elements are chemically bonded. These elements I can possibly separate by physical or chemical means. And the last thing is, they basically, since it's chemically bonded, this is caused by a chemical reaction. They have reacted to each other. Chemical reaction. And the compound usually has very distinct properties, very different properties from the elements that it's combined. So for example, we'll use two pretty common substances that we often talk about when we're saying difference between compounds and elements. So I have hydrogen and I have oxygen. Okay? Both of these substances are gases at room temperature. All right? They're basically invisible gases at room temperature. Both of them, if I put a flame next to them, will basically blow up in some cases. Okay? They can be explosive. Obviously, oxygen is what causes the explosion. Hydrogen can cause an explosion as well. All right? So if I put a flame, they're going to blow up. They're basically flammable, okay, if they're completely pure. The thing is, if they chemically react, we form H2O, which we know as water, which we can now drink. We can now, it's a liquid at room temperature, not a gas. It has many different properties from the elements that's made up out of it. Hydrogen and oxygen being flammable gases. Water's not flammable. Water puts out fires for the most part. Okay? So it becomes something brand new. The other one I like to always share, sodium and chlorine. Okay? And I'm adding the two because chlorine doesn't come as a single atom. It comes as what's called diatomic. So sodium is a metal. It is a solid. It's basically a gray silver color. Okay? And it will explode in the air. It basically reacts to the water in the air and it can explode. Chlorine is a yellowish green gas and highly poisonous. Okay, so we have an explosive metal and a highly poisonous yellowish green gas. They then react with each other. They will form sodium chloride, which is table salt. So all of a sudden, this explosive metallic yellowish-green gas elements, when they combine, all of a sudden become something that we eat. Okay? It's kind of crazy. It's just when they combine to form this compound, those individual elemental properties basically completely go, and we have something brand new, it's made up of these elements, but not representative of what they are individually. They have very individual, as it says, distinct properties. So pure substances, elements, and compounds. Mixtures, there's three types of mixtures: solution, suspension, and colloid. So the thing is with solutions, we have two types, okay? Mixtures. We got not solutions. We don't have two types of solutions. We got one type of solution. So solutions, first off, they are called a homogeneous mixture. Solutions are a homogeneous mixture. Homo meaning same. Okay? Same. What this means is that the object looks completely uniform. Okay? Again, what I mean by uniform is it all looks like one part. It says you cannot see the individual parts that make up this solution. So I have lemonade right there. Again, you can make certain types of lemonade where you can see the particles, but if you make basically a lighter lemonade, the water and lemon powder basically mix completely, and you can't sit there and be like, let me grab the lemon and let me grab the water. It's impossible. They're completely mixed together. Okay? So the particles themselves are very, very small, the ones that dissolve, that go into the water. They're too difficult to see, and so the whole substance looks the same. So basically juices, Powerade, Gatorade, things like that, those are solutions. Salt water, a solution. okay? A homogeneous mixture. All right, so the big thing about solutions, some of their properties. You can't filter a solution, okay? You cannot filter a solution. Again, where you basically put it over filter paper like coffee, all right? So if I pour lemonade through a filter, we're going to have lemonade out on the other side. The filter is not sensitive enough to separate out the lemon particles, the lemonade particles, whatever you want to call it. There are two parts to a solution, a solute and a solvent. Okay? A solute is what is dissolved, as I write here, what disappears. A solvent is what's doing the dissolving agent. Okay? You usually have more solvent than solute. All right? If you have too much solute, some of that solute will go to the bottom and it doesn't dissolve. So again, the solute goes in the solvent, is what we're looking at here. The solute goes in the solvent. Okay? All right. The thing is, just because it might come up quite a bit, the most common solvent is water. Okay? The most common solvent is water. And so since this is so common, we call any solution with water as the solvent it's called an aqueous solution. All right? So water, if you see salt dissolved in water, salt is the solute, water is the solvent. Lemonade's dissolved in water. Lemonade's the solvent, or solute. Water's the solvent. So solute and solvent. Think about what you're adding, that's going to be the solute. Then we have two what are called heterogeneous mixtures. The first one is the suspension. This means, as it says, it's not uniform. You can clearly see the different parts. Okay? You can see the different parts that make up the mixture. So the salad that we had on the prior pages a couple ago, that would be a heterogeneous mixture. Okay? We can separate suspensions with a filter. The particles are large enough. If you pour basically Italian dressing through a filter, you're going to grab all the little tiny peppers and particles that are floating in the water and the oil. Again, that would be a suspension. The fact that if you have water and oil, okay, you can sit there, yep, here we go, trying to do a good drawing. You could sit there and have the water on the bottom, and here's the oil on top. Okay, that would also be a suspension. All right, because they won't mix. Even if I shake them up, little oil particles might come into it, but I can see them and then they'll separate back out again eventually. Okay, so suspensions, you can see all the different pieces. What I have over here is basically muddy water. Muddy water is a suspension. You can basically filter out that mud and try to make the water eventually clear again. The last heterogeneous mixture, the last mixture, is called a colloid. I know it looks like colloid or something like that, but it's pronounced colloid. This one we don't need to know that much about. Basically, the particles are between the sides of a solution and suspension. All right, so they're smaller than a solution, or larger than a solution, but smaller than a suspension particle. These particles, we say they don't exactly completely settle, and it's because of something called Brownian motion. Unfortunately, you can't see me in class. Brownian motion is basically this very erratic movement of the particle because they're constantly colliding with each other and they have enough energy to never settle down, essentially, so they keep on moving all over the place. Examples of colloids, basically these are the only three you really need to know. Milk, I know a lot of people want to say it's a solution. Milk is a colloid. Blood is a colloid. Fog is a colloid. It's a gaseous colloid. Okay? So these three things basically are colloids. All right. The one way that you can really figure out whether you have a colloid or a solution, because colloids look like solutions, is they do something called the Tyndall effect. And what that is where you pass a beam of light through the colloid and you'll create this perfect clear beam through the liquid. All right? Because the particles are big enough where they basically cause that the light interacts with them and they almost create a boundary where the light passes perfectly through in kind of a nice straight line. If you shine a light through a solution, the light disperses. The light would go everywhere and would not be a perfect nice beam. Okay? So that's where we see the Tyndall effect. You actually are seeing the Tyndall effect some when it's foggy outside. If you've ever driven in the rain or in the fog, and you turn your lights on, it's sort of the reason why they don't travel very far. They have trouble passing through the colloid particles of the air, okay, in the air, I should say. All right, so those are the different types of mixtures and pure substances. So what I want to quickly do is I have this chart which I use for my class, basically breaking down the different types of matter. So what I would have here is basically, I would have, there are pure substances and mixtures. Okay, you can write in that obviously pure substances are one type of matter, while mixtures are multiple types of matter. Okay. Again, you might want to say they don't chemically react. What are the two types of pure substances? We have elements and compounds. Elements are one type of atom. And then down at the bottom here, I know I should scroll up more, but that's okay. I would just write in, like, give me examples. So I've said gold, we got oxygen, we got, basically pick any element off the periodic table. Okay? Compounds are two or more types of atoms. And we wrote down water, sodium chloride, we can say carbon dioxide, that's fine. What about mixtures? We got solutions. Okay. Actually, I think the way I have this set up, let me go back. I think I have homogeneous, and this is heterogeneous. And homogeneous, we got solutions. Basically, you write solute, solvent. And then examples, juice. I'm just going to write that. You can write other ones down if you want. Heterogeneous, we got colloids. I'm going to write Tyndall effect. I'm just going to write Tyndall. And we got suspensions. We can write salad for suspension. And we can write milk, blood, fog, etc. for, FG. Fog for colloids. Okay? And that's basically it. All right. Thank you.